Longtime residents of the Front Range of the Colorado Rockies are used to the occasional severe windstorm. They're also used to long stretches of warm, dry weather and wildfires from time to time, typically in remote areas. What happened last Thursday was a combination of the worst of these elements, resulting in the most destructive wildfire in Colorado history. Now, the fire burned about 6,000 acres, a bit more than 9 square miles, about 20 miles northwest of Denver, just a few miles southeast of the National Center for Atmospheric Research, which is in Boulder. To understand what conspired to produce this disaster, we need to start in spring of last year. Here's the percent of average precipitation in Colorado from March to May. All the green in the eastern half of the state means a very wet spring. The Denver area had of order 1.5 times average precipitation, and so vegetation growth along the Front Range was off to a fast start. But then the switch flipped. Here's the percent of average precipitation from June until the day before the wildfire. The same area that was so wet in spring got only about half the average precipitation the rest of the year. Plus, the last 7 months of 2021 was the warmest such period on record there. And this led to a dramatic change in the drought situation in eastern Colorado, from nothing on June 1st to extreme drought in the Denver area by late December. All that vegetation growth from the wet spring dried out and provided kindling for the fires. And very strong winds spread the flames. This is the heart of severe downslope windstorm season in that part of Colorado. Now to get these severe windstorms, you need westerly winds through a deep layer blowing perpendicular to the mountains. The flow accelerates as it descends the eastern slopes. That's enhanced if there's an inversion aloft, a layer in which temperature increases with height. That helps transport fast-moving air towards the surface and can also create waves in the flow downstream of the mountains. You can kind of see those undulations in visible satellite imagery as the smoke blew eastward from the fires. The wavy pattern was even more striking from the ground. This time-lapse view of the plume from the south shows the smoke acting as a tracer that outlines the waves. If there wasn't smoke, all you'd see are the clouds that form at the wave crests. The exact origin of the blaze isn't known yet, but it quickly became an urban firestorm. Nearly 1,000 structures, mostly homes, were destroyed, more than 100 damaged, nearly double the loss from Colorado's previous most destructive fire, at least partly because in this area, more neighborhoods are sprouting up right at the interface with wildlands, increasing the fire risk. As an example, one of the towns affected, Superior, Colorado, had a population of only around 250 up until the late 1990s. Last Thursday, the entire town, now numbering 13,000, was evacuated. Remarkably, because of those evacuations and high public responsiveness, there are no confirmed fatalities from the fire at this time, though 2 people are unaccounted for. Stay tuned. Our extended forecast is next.